Here are your solutions to 7-7, the letter problems. Starting with letter A. First of all, we have triangle LMN, the first triangle here, similar to triangle PQR. So you can see that we had a reduction in size. If the perimeter of LMN is 64 meters, what is the perimeter of PQR? So the first thing I would do again is I would write the 64 right on that so that we see that this is the perimeter of this. And again, I think the simplest way to do this problem is to do the perimeter over, so we have 24. Now the first thing that you should notice here is that the orientation is a little bit different here. So let's redraw this triangle here so that the longer piece, this piece right here, is looking left rather than to the right. And then of course that would put the 18 over to here. So now we have corresponding sides of 18 and 24. So we have 24 is to the side 18 as 64, the perimeter of the larger, is to the smaller. So we should recognize right away we're going to get a number smaller than 64 here. So we have 24 over 18 equals 64 over x. That's going to give us 24x equals 1,152, and we have to divide both sides by 24. These numbers should be familiar. And we have, once again, 48. In this case, 48 feet. Notice that these numbers were very similar to sample problem number 2. Okay, let's solve problem B. Two quilting squares are shown. The scale factor is 3 to 2. So obviously the 3 belongs over here and the 2 belongs over here. What is the perimeter of square TUVW? So we're looking for the perimeter here. So we have a 4-inch side on this side, a scale factor of 2 to 3. So we could look at it this way. We have scale factors of, let's go, 3 over 2 equals x over 4. Because the 3 belongs with this side here, x here, and the 2 belongs with the 4. So we have 3 over 2 is the same at 3 over 2 going this way, the same as x over 4. Once we've got that down pat, we can see that we've got 2x equals 3 times 4, which is 12. That makes x equal to 6. Of course, we divided both sides by 2. So we have an answer of x equals 6. So because our side length is what we found there, we now have to take 6 times 4, because of course each of these would be 6. This would be 6 here, 6 here, 6 here, 6 here, and 6 times 4 of course is 24. And if we look, we've got a scale, a unit of inches. So we have 24 inches for our perimeter. Really be careful when you do these types of problems to answer the question they're asking. They're asking for the perimeter. By using a proportion to solve this, what you really found was a side length, so you had to take all 4 sides. All right, let's do problem C. Malia is painting a mural on her bedroom wall. The image she is reproducing is 4.8 inches by 7.2. Let's do that right away. 4.8 by 7.2. If the dimensions of the mural are 10 times the dimensions of the image, find the area of the mural in square inches. Well, one way we could do this problem is to calculate this area here. So if we multiply 4.8 times 7.2, we get 34.56, 3456 with a decimal. Okay, so that is our area. So we would have to take this 34.56, that's the area, times our scale factor, 10 squared. Or in other words, times 100, which means, of course, we move the decimal place 2 points, and 2 places, I should say, and we have 3,456, and our units are square inches. The other way to do this would be to say, okay, if it's 10 times the size, we can take 4.8 and just say that that's 48 because we're going to multiply that by 10. And the other side, instead of being 7.2, would be 72, and just multiply 48 times 72. And again, of course, we get the same answer of 3,456 inches, and it's inches squared. Now let's do our guided practice problems. Problem number 1. In this case, we're given the perimeter here of 18 and a side length of 3, and a perimeter here that we're looking for with a side length of 4. So we could look at this and say, well, we have a side length of 4, and clearly there's 6 sides, so it's a matter of just 4 times 6, and of course our answer then is going to be 24, and it's in centimeters. Another way to do this problem would be to set up a proportion where we have 18 over x, right here, 18 is to x as 3 is to 4, as 3 is to 4. And we would have 3x equals 72. So we divide both sides by 3, and we end up with x equals 24. And the third way we could do this problem would just be to recognize that we have 3/4 is or 4 over 3 is our scale factor because it's becoming larger. So we have 4/3 as our scale factor. We'll do the math over here. So if we take our perimeter of 18 and multiply 18 times 4/3, this would cancel out to 6 over 1, and that again would be 24. So 3 different ways to do this same problem. Your answer is 24 centimeters. Problem number 2. In this case, I won't do all the different ways you could do it. I'll save you a little bit of time, but I want you to recognize you should find a way that works well for you, that you truly, really understand it. Don't just memorize it, but understand it. So one way we could look at this, again, we're looking for perimeter, is we have 21 is to x as 5 is to 2. So we have 5x equals 42, divide both sides by 5, and we have x equals 8.4, and we'll put it over here, 8.4, and we can see that feet is our unit. Problem number 3. Julie is enlarging a digital photograph on her computer. The original photograph is 5 by 7. If she enlarges the dimensions 1.5 times, what will the perimeter and area be of the new image? So we're going to do both perimeter equals and area equals. We're going to do them both. First of all, one thing you could do for the perimeter is you could say that we have a side of 5 plus 5 plus 7 plus 7. That's the perimeter of the original one. So we'd have 10 plus 14, that's 24. And then multiply that by 1.5, and our new perimeter would be 36. So we're going to put this over here. Our answer is 36, and we're in inches. Another way to do this would be to multiply each side. So 5 times 1.5, so 5 times 1.5, 5 times 1.5 equals 7.5. That's our new dimension. The other side of 7 times 1.5, 7 times 1.5 equals 10.5. So now we have side lengths of 7.5 and 10.5, but we have 2 of those. So 7.5 plus 7.5 equals 15. I'll write it over here so I can add this. And 10.5 plus 10.5 equals 21, and add that up, and we have 36. So 2 different ways to get 36 inches for the perimeter. The area is 5 times 7, which of course is 35, and then we're going to multiply that by 1.5 squared, and that is going to give us an area of 78.75 square inches. So our area is 78.75 inches squared. Now remember, we also over here figured our new dimensions. Our new dimensions were 7.5 by 10.5. So if we multiply 7.5 times 10.5, we of course get the same answer of 78.75. 2 different ways to do these problems. Problem number 4. Logan is flying a kite that is made up of 3 similar rectangles. The sides of the 3 rectangles are in the ratio of 1, 2, 3. If the area of the smallest rectangle is 72 square inches, so we're doing area here, we have 72 square inches, so we have the first area of 72 times the first scale factor. Well, the first scale factor from 1 to 2 is, of course, 2, and we're going to square that scale factor. So 72 times 4 is 288. So our first answer is 288. Find our unit here, square inches, so inches squared. Now in the next case we have 72 times the scale factor here is 3, but it's 3 squared, so 72 times 9, and we get 648. And again, it's 648 inches squared. And lastly, our essential question. If you know two figures are similar and you're given the area of both figures, how can you determine the scale factor of the similarity? So what they're doing here in this case is they're asking you kind of to work backwards. So remember, what we would do if we were working forwards is we would multiply by the square. We would multiply by, let's put it right over here, the scale factor squared. So since we're working backward, we would write the ratio of the two areas and then take the square root of the ratio in order to get back to this number that was inside here that we squared. Remember, that's the purpose of understanding what square root is all about. Please do independent practice.